6.1 Introduction to Vectors. So here is a scalar versus vector. What is a scalar? A scalar is quantities that it is just a number. There is no direction. It has unit, but it doesn't have any direction. Like what? Like time. Time is just a number, it doesn't have any direction. Also like a mass. Mass of an object is just a number, like 5 kilograms. Doesn't have any direction. Vector is quantities that it has a magnitude, is a number, but it has a direction as well. So it's like 2 meters per second to the west or 5 meters to the east. So they have a magnitude and direction. If you want to classify this, let's do time. Time is a scalar, it doesn't have any direction. Position. Position is a scalar, just have a number. Temperature is a number, is a scalar. Electric charge is a scalar, it's just a number. Mass is a scalar, it just is a number. Force, it has a direction and magnitude, so it is vector. Displacement has direction and vector. So direction and magnitude, so it is vector. Third scalar is distance travel, speed, mass, they are scalar vectors, displacement, velocity, force. Now, if you want to represent a vector with a word, we can do that. Let's say we can say 5 kilometers at an angle of 30. So I can draw this as a diagram, right? So I just draw that. Here is 5 kilometers, 30 degrees to the horizontal. So the angle to the horizontal is 30 degrees. We can put it as a symbol. Here is AB. The beginning of that is A. The end of the vector is B. If I want to represent that as symbol, I say AB and I put a symbol of the vector above that. Okay, so magnitude of the vector, I can put absolute value in front of the AB. So magnitude of the vector is just a number. Let's say this is 5 kilometers. Or the magnitude of the velocity, I just put absolute value of that. So it's going to be, let's say, 2 meters per second. Absolute value of that means the magnitude, how big it is. So 2 ways to express vector diagrams. We can do bearing. When you talk about bearing, you measure it from north and you do go clockwise. Let's say here is the bearing of 0. It means it's just exactly at north. Bearing of 30 means you start at north and you go 30 degrees clockwise. Bearing of 300, you start at north and you go 300. So bearing is a measure from north. So quadrant bearing, when you talk about quadrant, you know, like north 23 west. So as you know, we have, this is east, this is west, this is north, this is south. North 20 degrees west, so is here, north 20 degrees west. Sorry, this is east. Let me just erase this, say it again. North 20 degrees west, so you have to do this. This is 23 degrees. And you put the arrow here. South 20 east. So we start at south 20 degrees to the east. Because this is east, this is south, right? South 20 to the east. So we start that and you go to 20 degrees to the east. So we call this one quadrant bearing. Now from horizontal, when you say, let's say 45 to the horizontal, you just simply draw a line that is making angle 45 with the horizontal. What is the definition of the parallel vector? Any two vector that has the same direction. So let's say this vector and this vector, doesn't matter, I move them around, they are also be parallel, right? Any vector that has same direction, but it could have a different magnitude, is parallel, they never reach each other. So equivalent vector are a vector has the same magnitude and have the same direction. Okay, and opposite vector, the vector that has same magnitude but opposite direction. Like here, these two vectors are opposite, they have the same magnitude but in opposite direction. So like AB is negative, opposite of the AB is negative AB. And you put a negative, these two will exchange, become BA. Now, for the worksheet, you can do question number 1, question number 3, question number 4, ABC, question number 5, ABC, question number 6, you can do question number 7, B, and question number 8, A, B, C, and D.